Module 7 is about flow processes for mass and energy balances. And the course outcome for this module is the ability to acquire and explain the basic concepts in thermodynamics and to comprehend and apply the concept to the actual conditions and problems such as closed and open system, and also to apply and correlate the concept with the appropriate equations and principles to analyze and solve engineering problems. Okay, by the end of the chapter, students should be able to explain about the mechanisms of energy transfer for an open system and write down the general energy and mass balances for an open system and simplify the energy and mass balances for steady flow system. Okay, this is the contents that we will cover for this module, which is the energy balance for open system, the conservation of mass, the flow work and energy of flowing fluid, and energy transport by mass. Okay, energy balance for open system. Okay, previously we have discussed about the general energy balance for closed system. So this time we will discuss about energy balance for open system, and we can see the difference. Okay, so this is a diagram of open system, which we have mass in and mass out, and also we have the we can also have Q in and Q out at the same time, work in and work out. Everything is open, okay, for open system. So generally this is the general energy balance for energy equation, general energy balance equation. But this time, okay, this is the Q in minus Q out plus work in minus work out. But this time, for open system, we have an additional equation, which is E mass in minus E mass out. Okay, so that's the difference between open system, we have this, and closed system, we don't have this. Okay. Okay, conservation of mass. Conservation of mass. Mass is like energy. It's a conserved property and it cannot be created or destroyed during a process. So for the closed system, the mass of the system remains constant during a process. But for control volumes or open system, mass can cross the boundaries, and so we must keep track of the amount of mass entering and leaving the control volume. So we have mass in, mass out, and so the mass might be changes as well. Okay. So mass flow rates, okay, mass flow rates, remember, if you have dot at the top, it shows that it is over the time. Mass flow rates, mass flow rate is also equals to volumetric flow rate multiplied with density. So this is volumetric flow rates, okay, volume flow rates, which is the density is also equals to 1 over specific volume. So therefore mass flow rate is equals to volumetric flow rates over the specific volume. Okay, so this is the equation for volume flow rates. Volume flow rates equals to V average and cross sectional area. Okay. Okay, so this is the average velocity. Okay, V average. The average velocity is defined as the average speed through a cross section. So this is a bulk fluid. Okay, when it flows, how do we identify for single velocity of the particles? So it is hard to identify for individual particles. Okay, therefore we can try to find the average velocity. Okay, just to estimate. Okay, so the average velocity, the unit is meter per second, and this is the cross sectional area, meter square. Therefore we have volumetric flow rate. Okay. Okay, this is the cross sectional area. Okay, the cross sectional area. So this is the average velocity. This is how it occurs in a tube, maybe in a piping. This is the cross-sectional area, that where is the velocity cross. Okay, so the volume flow rate is the volume of the fluid flowing through a cross section per unit of time. Okay, over the time, over per second.